multiplying and dividing with exponents. All right, so here's an example of a number in exponential form. So the whole thing is the power. So when I say the power, I mean everything. So 5 to the second power is a power. I know that's confusing. The little number, that's the exponent, and the exponent is telling you how many factors you have. That's all it tells you. It doesn't tell you what you're multiplying, just how many numbers you are multiplying. Oh, and by the way, if it's in a green circle, in your book, I'm giving you a suggestion of where you could take notes. This is not on page 71, but the bottom of page 71 has a nice blank spot that we're not going to use for anything else, so feel free to take these notes on the bottom of page 71. So we need to know that the little number is the exponent, and the exponent is how many factors you have. The big number is the base, and the base is the number that is being repeatedly multiplied. Okay? So 5 to the second power means we have 2 factors of 5, right? 5 to the second power, 2 factors of 5. And we call this expanded form. So expanded form is when we are writing an exponent as repeated multiplication. So these mean the same thing, 5 to the second power and 5 times 5, but this is expanded form and this is exponential form. It's important that you know this because on your next quiz, I'm going to ask for either expanded form or exponential form, and you need to know which one's which. Another example, if we had 4 to the 5th power, our base is 4, so that's the number that's going to be multiplied. So all of our factors will be 4s. And the exponent is just telling us how many factors of 4 we will have. We have 1, 2, 3, 4, 5 factors of 4. So here we have exponential form, and here we have expanded form. All right, so here's our first example. It's in your book on page 72. So we're going to multiply 7 times 7 times 7 times 7 times 7 times 7 times 7. So 7 factors of 7. But we're going to group them in different ways. The associative property of multiplication says that as long as it's all multiplication, I can group it any way I want. So I'm going to group 3 of my 7s together to make 7 to the 3rd power. And then I'll group 4 of my 7s together to make 7 to the 4th power. And I know that this is equal to 7 to the 7th power because that's what I started with, 7 factors of 7. Or what if I group 7 times 7, so 7 squared, and 7 times 7 times 7 times 7 times 7, which is the rest of the 7s, which is 5 of them, right? This still is equal to 7 to the 7th power. So our rule, notice that when we multiply powers with the same base, we're actually adding up the exponents, which makes sense. This is saying I have 3 factors of 7. This is saying I have 4 factors of 7. So I'll add them up to get a total of 7 factors of 7, which, if you multiplied it out, would be 823,543. Go figure. Most of the time, I'm going to want your answer in exponential form. So please don't spend a lot of time multiplying these out. It's really tedious if you don't have a scientific calculator, and it's not that educational. So if you're not sure, leave it in exponential form, unless I specifically say multiply it out. Okay, so here is our first rule. Rule number 1. You are going to need to write this in your book, and you're going to need to memorize this. And we're going to have a bunch of rules, so memorize the 2 we're learning today before I throw more rules in for you. So the rule is when you multiply powers with the same base, that is very important, you add the exponents together. And here we have an example. So we have x times x, which I could write as x squared, times x times x times x, which I could write as x cubed. Well, I could count them, 1, 2, 3, 4, 5, or I could add the exponents together. Whoops, 2 plus 3 gives me 5. So this is x to the 5th power. And this is writing it in exponential form. You notice they said write the answer in exponential form? That's this. Don't give me x times x times x times x times x. That is expanded form. Okay, let's practice this a little bit. So we got 4 is 3 to the 9th power times 3 to the 3rd power. Do you see why we have the rule? 9 factors of 3? Who wants to write 9 factors of 3? That's painful. I think that's it. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 3 more factors of 3. So this is expanded form. I could write them all out. I could count, right? But how much easier and more elegant to just add my exponents together and get 3 to the 12th power, which is your answer. So let's look at number 5. A to the 7th times a to the 4th. I'm not going to write 7 factors of a and 4 factors of a. I'm going to add the exponents together because when I multiply powers with the same base, I can add the exponents to get my new exponent. So a to the 11th power. These 4 problems are not in your book, but I thought we needed a little extra practice so you could write them in somewhere. We're on page 72. So 3 squared times 3 squared is going to be 3 to the 2 plus 2 power, or 3 to the 4th power. Now you could multiply this out. 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So 3 to the 4th power is 81. And we actually have a name for this. We call this standard form. Standard form. Most of the time, I do not want you to multiply it out. Most of the time, you don't want to multiply it out. It's a lot of multiplying. If you have repeated multiplication, I want you to write it in exponential form, please. All right, so 2 times 2 squared times 2 squared. So if I wrote this out as factors, it'd be 2 times 2 times 2 times 2 times 2. And you can see there are 5 factors of 2 there. When I use my rules to add it up, I have 2 plus 2 plus, do you see how there's nothing there? And it's tempting for students to just add 2 plus 2 and get 4 and miss this factor completely. We don't put an exponent of 1 because it's kind of obvious there's only one factor of 2 there. But if you are adding your exponents together, you need to put a factor of 1 there or you will not get the right answer. So remember, any factor that does not have an exponent has an invisible 1 floating up there that you can write in so that you can use your rules of exponents. Problem number 5. Now, problem number 5 looks like 2 terms, does it not? Would you be tempted to circle these 2 and say 2 terms? Don't be. That would be wrong. There are not 2 terms here because we know that terms are separated by addition. And there is no addition here. This is multiplication. What we actually have is 2, a factor of 2, times a factor of n to the 4th, times a factor of 5, times a factor of n to the 4th. These are 4 separate factors. They look like they're grouped together just because when we put a number in front of a variable, we just put them right next to each other to indicate multiplication. We don't usually put the dot in. But it's still just multiplication, and I could put the dot in so that you can see we have 4 factors and all one term. In fact, all of these problems are all one term because none of these problems have any addition in them. So I could rearrange this using the commutative property of multiplication and make this 2 times 5 times n to the 4th times n to the 4th. And then I would multiply the 2 times 5. There's no repeated multiplication here, so I'm not going to use exponential form. I'm just going to write 10. And then I can add 4 plus 4 and get n to the 8th power. N to the 8th power. There we go. All right, number 6. Again, this is 6 times r times 5 times r squared. These are just 4 factors. This 6 does not belong to the r. It's just a factor of 6 that happens to be next to this r. And I can rearrange them because the commutative power of multiplication says that I can. And while I'm rewriting this, I'm going to put a 1 on this r so I remember that its exponent is 1. So 6 times 5 is 30. And r to the first power times r to the second power, I can add the exponents together and get r to the third. Wow, that is messy. Let me try again. 30 r to the third. Is that better? Okay, so now we are on to division. So here we are dividing a power by a power with the same base. And we're going to use expanded form to show you what's going on here. So 7 to the fourth power we wrote as 7 times 7 times 7 times 7. 7 to the third power we wrote as 7 times 7 times 7, right? And then it's our good friend canceling. Do you remember canceling? Yeah, let's cancel. So 7 divided by 7 is 1. 7 divided by 7 is 1. 7 divided by 7 is 1. And everything canceled except for this 1 7. So 7 to the fourth power divided by 7 to the third power is 7, right? Here we have x to the 8th divided by x to the 5th. So I could draw 8 factors of x in the numerator and 5 factors of x in the denominator. But I know that I'll be able to cancel 5 of these 8 factors, right? With the 5 x's in the denominator. I guess I should. They told me to. So for A, they said rewrite it in expanded form. 1, 2, 3, 4, 5, 6, 7, 8. And then in the denominator, I'm going to have to fix that one. That one's too bad. Let's try it one more time. Pen. A little better. And then 5 factors of x in the denominator. And then we cancel what cancels. Why not magenta? So this x cancels this x cancels this x. Oops, got ahead of myself. So, and then one more x. So these 4 factors of x cancel these 4 factors of x. And what am I left with? I'm left with 4 factors of x. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Gosh darn it. So I needed one more in the denominator. And then, of course, I got to get my magenta back so I can cancel. Sorry, this must be painful to watch. My apologies. X to the third power is my answer. Did you figure out the rule? How could you simplify the original expression without writing it in expanded form and canceling everything? There it is. Rule number 2. When you divide powers with the same base, that's important, it's got to have the same base, you subtract the exponents, right? So 7 to the fourth divided by 7 to the third, I could write as 7 to the 4 minus 3. Always subtract the exponent of the numerator minus the exponent of the denominator. And we know 7 to the first power is 7. Here, I could do x to the 8th minus 5th power gives me x to the third power. Always the exponent of the numerator minus the exponent of the denominator. Make sure you write down the rule in your notes, please. All right, a little bit of practice. I don't want to write 15 factors of 12. You don't want to write 15 factors of 12, so let's use our rule. When we're dividing powers with the same base, we can subtract the exponent of the numerator minus the exponent of the denominator, and we get 12 to the 5th power. I don't want you to multiply this out. Do not multiply 12 times 12 times 12 times 12 times 12. That would take too long, and it's an enormous number. Just leave it 12 to the 5th power. All right, here, remember that r is r to the first power. So when I subtract my exponents, it's going to be r to the 9 minus 1 power, which is equal to r to the 8th power. All right, again, these problems are not in your book. Little extra practice I thought you could use. You can write them in. Here we have 2 to the 4th power divided by 2 to the 2nd power. So I'm going to subtract the exponent of the numerator minus the exponent of the denominator, and I get 2 squared. Ooh, look at this. Again, it looks like that 3 belongs to the r, but it does not. This is 3 times r cubed divided by 2 times r. So this 3 and this 2 doesn't mean that these are terms. Again, this is all one term. Every problem on this page is all one term. This 3 over 2 is already a simplified fraction. Please do not change it into a decimal. Just leave it as a simplified fraction. So we have a 3 in the numerator and a 2 in the denominator, and that's fine. Here, remember that r in the denominator is r to the 1st power. So if I subtract my exponent of the numerator minus the exponent of the denominator, I get r squared. And whenever you simplify powers that are being divided by subtracting, the answer you get ends up in the numerator, right? These are all numerators here. We just don't usually put the 1 underneath. So when you have powers that are being divided, you can subtract the exponents, but put your answer in the numerator. That's where it belongs. So this is the answer, 3r squared over 2. All right, let's look at number 7. Number 7, this is not a simplified fraction. Agreed? So I'm going to break out my good friend prime factorization. I told you we were going to use it over and over and over again all year long. I did not lie. So I have written my my numbers in prime factorization, and I have written my powers in expanded form. I can cancel this 2 with this 2. I can cancel this p with this p. And what I get is, in the numerator, 5 times 1, 2, 3 factors of p is 5 times p to the 3rd power. And in the denominator, 1 times 3 times 1 is 3. That is your answer. So not only do you have to divide powers, you also have to simplify fractions at the same time. You can do it. You can do it. It's not that bad. Okay, same thing for this one. So 12 is 2 times 2 times 3. X cubed is x times x times x. 9 is 3 times 3. And y to the 8th power. 1, 2, 3, 4, 5, 6, 7, 8. Let me tell you right now, if you draw your y's like that, you need to stop it right now, because that looks a lot like an incomplete x. I will not know the difference. You need to start making your y's with the little hook at the bottom or the loop at the bottom. No straight y's. Honestly, I will mark it wrong. If I'm not sure, it's wrong. So you do not want to tempt fate by making your y's that way. So please practice drawing y's that have a hook or a full loop at the bottom so they don't look anything like an x. All right, 3 divided by 3, that's 1. But do you see that none of these y's are going to cancel any of these x's? Yeah, x divided by y isn't 1. I don't know what x or y are, honestly. They're variables, so they stand for numbers I don't know. But if they have different variables, they're different numbers, so I cannot cancel them. Here, p divided by p stands for a number. Let's say it's 5. 5 divided by 5, that's 1. Let's say p was 20. 20 divided by 20 is 1. Let's say p was negative 8. Negative 8 divided by negative 8 is 1. Because they have the same variable, we can cancel them. If they are not the same variable, you may not cancel them. Please don't try. All right, so in the numerator, I have 2 times x times x times x. So that is 2 squared times x to the 3rd power. In the denominator, I have 3 times those 8 y's, so that's 3 y to the 8th power. I would also accept 4x cubed over 3y to the 8th, but I like this one better. But this one's okay. Full credit for either one of these answers, but this one's better. Alrighty, thanks.